Okay, today's lesson is on finding the slope and the rate of change. So write down the title. You'll need some graph paper for this particular lesson. Before we get started, what we want to do is solve for y, just as a practice. We're going to need this a lot for this unit. So if I want to solve for y, that means I want to isolate y and get it alone, and you've had practice doing this. So you can pause this if you would like, or you can follow along. So you're going to add 5x to both sides, so that's canceled. So I get 6y equals 5x plus 4, and then I have to divide everything by 6. Now, instead of putting the 6 under both of those terms, I'm going to divide each individual term by 6 this time, so that I get y equals, and notice I have 5 over 6, so I'm going to put that as a fraction and then put the x next to it. So I have 5 6x plus 4 over 6, which reduces to 2/3. And that's how we solve for y. Alright, let's try the next one. You can see that I want to solve for y. So I need to subtract 3x from this side, and then notice the equal sign. On the other side of the equal sign is where I need to subtract 3x. And then I have 5y minus 2. Bring down your equal sign. Now I'm going to add 2 to both sides. So I'm doing inverse operations to both sides. So then I get 5y on the left equals negative 3x plus 2. There's my equal sign, bring it down. Now I'm going to divide everything by 5. And again, I'm dividing each individual term by 5. So my answer will be y equals, and then see how you have the negative 3 over 5. I'm going to make that a fraction and put the x next to it, plus 2/5. And that is solving for y. All right, let's get on to our lesson. All right, this needs to be in your notes. First of all, delta looks like a triangle. Delta is a mathematical symbol for change. So make sure you know that when you see the word or the symbol delta, that means change. Slope. Slope is the ratio of the vertical change, rise, to the horizontal change, run, between any 2 points. The slope of a line is represented by the letter M. The slope M of a non-vertical line passing through 2 points, x1, y1, and x2, y2, is the ratio of the rise, the change in y, to the run, change in x. So have that written down. Basically, you have this. Slope is equal to the rise over run, which is delta y, the change in y, over the change in x. The change in your vertical over the change in horizontal. And then the formula for slope is m equals y2 minus y1 over x2 minus x1. All right, also you need to copy this graph in your notes. And you can see this is showing a line that's going up. And you have the rise. The rise is the difference between the y's. So you have y2 here. So all y1 and y2. y1 is the y value of one point, and y2 is the y value of another point. x1 is the same thing, the x of one point, and the x2 is the second point. So you're going to subtract y2 minus y1, that's going to give you your rise, and x2 minus x1, that's going to give you your run, and that will give us our slope. All right, once you have all of this in our notes, then we'll go on to the next page. All right, so example 1, you want to write these down. You have 5, negative 2, and negative 3, 6. Those are 2 points on a line. You can find slope if you have at least 2 points on a line. Then we want to go ahead and graph it. So you can see over here that it's been graphed, and I want you to graph it also in your notes. Okay, so let's look at the graph of this particular line. The slope is equal to the rise over the run, the rise over run, which is delta y over delta x. So the first point is going to be x1, y1, and the second point is going to be x2, y2. And so what you do is you're going to take the difference between the y's. So I'm going to take the y's and subtract them. So I take negative 2 and I'm going to subtract the 6. So y2 minus y1 over, and then I take the x's, so x2, which is 5, and I subtract the x1, which is a negative 3. And that's going to give me my slope. So negative 2 minus 6 is negative 8. And then 5, you keep change on that, so you get a positive 8. So your slope, which is m, is going to be equal to a negative 1. So now let's find it from the graph. We've done it with the formula. This is using the formula. The formula is y2 minus y1 over x2 minus x1. That's the formula. Now we want to do it from a graph. If you were going from this graph and you wanted to find the rise over run, what you would do is you would do the rise. So the rise is here. And how far up are we going? So 1, 2, 3, 4, 5, 6, 7, 8. So the rise, you're going up 8 here. Or if you do it from this point, you're going down 8. 1, 2, 3, 4, 5, 6, 7, and 8. Or you're going down negative 8. So if you're going from left to right, you're going to go down, and then you're going to go over. If you go from this point, you're going to go up, and then you're going to go over this way. So either way, you'll get the right answer. So if I start over here, which is where I was, and I start over here and I see I'm going from this point over to that point. I see positive because I'm going up here, but then when I go to the left, I go 1, 2, 3, 4, 5, 6, 7, and 8. So I go over negative 8. So my rise over run would be 8, positive 8, divided by negative 8. If I go the opposite direction, you can see that I just went down 8, and now I need to go over 8. So anytime you go to the right on the graph, it's going to be positive. So if I start here, 1, 2, 3, 4, 5, 6, 7, 8, this is positive 8. So you can see here the slope would be negative 8 over 8. Here the slope is 8 over negative 8. Either way, when you divide it out, you get a negative 1. So your slope is equal to negative 1. Let's try that again with a different problem. All right, example 2. Let's just find slope just using what we know about our formula. So let's take y2 minus y1 over x2 minus x1. All right, let's say the first point, let's say this is x1, y1, and the second point is x2, y2. Now what I'm going to do is subtract. So I'm going to take the y2, which is 6, subtract the negative 3, and then I'll take the bottom, the x2, which is 4, and subtract x1, which is negative 2. When I do that, I keep change, so I get 9, and I keep change there, and I get 9 over 6. And yes, you can reduce that. You could reduce that to 3 over 2. So that's going to be my m. That's going to be my slope. And technically, you should reduce it to the 3 over 2. Now, let's look at this on a graph. All right, so we've graphed the point, and you should get graph paper and pause and graph this. Now we want to be able to find the slope just from the graph. And remember, it's rise over run. And it doesn't matter if you start with the point on the left or the point on the right. You'll still get the same slope. So if I start with the the point on the left, I need to see what do I have to do to get to this point over here. So I'm going to see what I have to do to rise. So I'm going to rise 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's rising of 9. So I'd put plus 9. And then I'm going to go to the right, and I'm going to go 1, 2, 3, 4, 5, 6. So rise over run is 9 over 6. All right, so that's that point. Even if I went this way, if I did the run first, 1, 2, 3, 4, 5, 6, that would be my run. And then I could go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Either way, you get 9 and 6. Rise over run. Okay, then reduce that to 3/2, and I'll show you that that works as well. So if I were to, let me do a different color. If I were to start at this point here, at -2, -3, and I use the slope 3, 2, would it work? So 1, 2, 3, and then over 1, 2. That gives me a point. If I go 1, 2, 3, and then over 1, 2, yes, that gives me a point. If I go do it again, 1, 2, 3, rise, and then over 2, I still get that point. So this would be 3, this would be 2, this would be 3, that would be 2, that's 3, and that's 2. So you can see that 3/2 is also the slope in the reduced form. All right, on to the next part of our lesson. All right, now we have example 3. So remember that our formula is y2 minus y1 over x2 minus x1. The first point we'll say x1, y1. The second point x2, y2. So then I just plug in my numbers. 4 is y2, so I do 4 minus 4, that's my y1, over 4, that's x2 minus a -2, which is my x1. And that equals 4 minus 4 is 0, and then keep change, and you get 0 over 6. 0 over 6 is just 0. 6 will not go into 0, so that would be 0. All right, so let's graph this and see what it looks like. So you can see if you graph this particular line, you can see it is a horizontal line, and the slope is 0. So anytime you have a horizontal line, so all horizontal lines have a slope of 0. M equals 0. So we can prove this because the rise, there is no rise at all to get from one point to the other. So no rise, but the run is 1, 2, 3, 4, 5, 6. So no rise, but a run of 6, and that's going to be a horizontal line. Anytime you see a horizontal line, you just should know and memorize that the slope is 0. All right, here's another example. So in this example, we have x1, y1, and we have x2, y2. So our formula is y2 minus y1 over x2 minus x1. So y2 is 1 and y1 is 5, so I subtract those. And then x2 is 3 and x1 is also 3. So you can see 1 minus 5 is going to be -4, and 3 minus 3 is 0. So since we can't divide by 0, our slope is going to be what we call undefined. So the slope of this line is undefined. Anytime the 0 is in the denominator, that is an undefined slope, and you'll need to memorize that. Let's look at the graph. Okay, so the graph you can see is you have 3, 1 and 3, 5, and we've drawn a line through that. And so you can see that there is a rise of 1, 2, 3, 4. So rise of 4, but there's no run. It doesn't go left and right at all. So that would be 0, which again makes it M undefined. And all vertical lines have a slope of undefined. Vertical lines, M is equal to undefined. And you'll need to memorize that. Okay, let's go forward. Okay, for example 5, you need to be able to use the slope formula here, the slope formula, to be able to find a missing coordinate in 2 points. So, write this down. You have x9, that's 0.1, and then you have -1, 19, that's 0.2. And it tells you what the slope is. So if they give you the slope, then you can find the missing value of x. That's what you're looking for. So let's see what we need to do to solve this. The first step is to plug the numbers that you know into the formula. I know that the slope is 5. Again, this is the formula that I'm using. And I know that this, let's say this is x1, y1, this is x2, y2. So I know that y2 is 19, and then I have a 9 on top, or y1 is 9. And then on the bottom, I know that x2 is -1, and I don't know what x is, so I'd put minus x there. Now what I would do is use what I've used before, or learned in the last unit, is that I'm going to cross multiply to solve. So I can cross multiply to solve. So I'm going to make that 1, and I'm going to, first I probably can reduce this top, so let me do that. So it's 5 over 1 equals 19 minus 9 is 10. That makes it a little bit easier. Now what I'm going to do is cross multiply. So I get 10 is equal to, and then I have to multiply these, 5 times a -1 minus x. Remember, you have to distribute, and you can skip this step if you know how to do it. So then you have 10 equals, distribute this, you get -5, and multiply that, and you get -5x. And now you're just solving for x. So I would add 5 to both sides. So I would get 15 on the left is equal to, this cancels, -5x, then divide by -5, and I would get x is equal to a -3. And that's how we would solve if you have everything but one of the coordinates. Okay, example 6, write this particular problem down. It says you want to find the slope of this graph. So remember, on this, you can use the formula if you would like, but you also need to be able to just do rise over run. So delta y, the change in y, over delta x, the change in x. So you identify the 2 points. So here's a point and there's a point, and you should draw this on your paper or on graph paper. The rise, we're going to go from, let's go from the first point to the second point. And the rise, if you're going down, is negative. So if I go down 1, that's -1, -2, -3. So my rise is -3. And then if I go over 1, 2, my run is 2. So it would be -3 over 2. And you can just bring that negative out in front and just call it a -3/2. So that would be your slope. And notice that the line is decreasing and going down from left to right. Anytime a line is decreasing, you have a slope is negative. Anytime the line is increasing, you'll have a slope of positive. All right, let's go to the second one. You need to be able to find the slope from this graph. The first thing you do is identify 2 points on the line. So I'm going to graph this, and I have this point and I have this point. Now I'm just going to do rise over run to go from one point to the other. So I take the first point on the left, and I'm going to count the rise. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have a rise of 9. And then I'm going to run. So run 1, 2, 3, 4, and I'm going to run over 4. So the rise is 9 and the run is 4, and that would be your slope. Notice that the line is going up from left to right, so that means you have a positive slope. Okay. All right, the next and last part of our lesson is comparing rates of change. You'll need to write this graph down in your notes, or print it out and cut it out and put it into your notes. It's easy just to draw it. The graph shows the cost in dollars to mail a letter over the years. So you have the years on the bottom and the cost. And you can see that what these numbers mean is that in 1991 it was 29 cents to mail a letter, 1995 32 cents, 1999 33 cents, and so on. So what we want to do is for A, we want to determine the time interval during which the cost to mail a letter showed the greatest rate of change. The greatest rate of change is going to be the steepness of the line. So if you look here, this is the steepest part of the line. Okay, it goes up the most right here. So what you want to do is you want to find the rate of change from the first point to the second point on this segment of the line. And the way we're going to do that is we're going to do the rate of change is the change in the cost, change in Y, over the change in year, which is your X value. So if we look at this point, the first point right here, and then we have the second point. So the second point is going to be 2002 and 37 cents. So I'm going to let that be my X2, Y2, and then my X1, Y1 would be the first point, which is 2001 and 34 cents. So I'm going to look for the rate of change. So I take the Y2, which is 37 cents. I subtract the Y1, which is 34 cents. And then I subtract the 2002, the Y2, minus 2001. So I would get 3 cents in that particular year. So it'd be 3 cents a year would be the greatest rate of change. That's the greatest rate of change. Now it says determine for B, determine the time interval in which the cost showed the least rate of change. Well, the least rate of change is going to be where the flattest part of the line is. So we need to look on the line and see where is the flattest part of the line. It's not there. It looks like it's going to be from here. That's the flattest part to me. So let's look at the 2 points, each point, and we'll find the rate of change. So if we write down these 2 points here from this point to this point, all right, the point, the Y2 is going to be 1999 because that's the second point. So that's your X2, Y2. And then your first point is this one here, which is 1995 and 0.32. And that's going to be your X1, Y1. Now I'm going to do the change in cost. So I do 33 minus 32. And then I do 1999 to 1995. And when I do that, I'll get 1 cent in 4 years, 94 years. And I can reduce that to say that it would be basically 1/4 cent per year. 1/4 of a cent. So if you have 1 cent every 4 years, that makes it 1/4 cent per year. And that's going to be your rate of change for 1999 to 1995. All right, we've discussed slope. Make sure you do a whisk on this. When and where did you watch it? Summarize what you know about slope, what the formula is, what it means, what all you've learned from this particular video, and then any questions that you might have, and please bring those up in class. Thanks for watching.